In this video, we'll be looking at how simple models, which we refer to as n-gram models, make predictions about the next word, right? So having a basic understanding of how these simple models work would help you to actually find out the larger ones work as well, right? So let's get into it. In the last video, we talked briefly about, we did an introduction into large language models. We kind of went through a couple of examples to show how they predict words, right? So we also learned from the last video that most of these models are trained from a large training data, which we call corpus, right? It's called a set of tests, right? And also learned in the last video that this text actually turned into numbers and then back into text. So that's pretty much the flow. So if you've not seen that video, I would encourage you to go to that video and watch that first before you come into this, before you watch this one, because it gives you a basic understanding, a foundation into what we'll be talking about today. Right. So today, like I said earlier on, we'll be diving deeper into, the fascinating realm of n-gram models, which are pretty much tools that help us predict the next word in a sequence. So, what exactly are n-gram models? In a simple term, you can define them as, models that look at sequences of n, in quote, words, to predict the next word. So, for example, a bigram model will look at the last word. So, a bigram model is when the n equals to 2. So, before this video ends, we'll definitely have a play around, to see how this works, because I actually wrote a Python code for this course to show you, because it's better to see than to just, read and hear about it. These models rely on something called the Markov assumption, right? This principle that says that, it simplifies the prediction process by assuming that the future is a function of only a few recent words. So that's basically the summary of the Markov assumption. It just assumes that whatever future word you're looking at is a function of a few recent words or the previous words, right? So, for example, looking at this formula, if you're looking at a bigram model, the n will be 2 minus 1. So it's the bigram model will consider just one word to predict the next word. Whereas for a trigram example, you're going to have 3 minus 1 words context, right? Context window. So it's look at 2 words before, it will consider 2 words to predict the next word. And for example, if you have like a 7-gram model, it's going to consider 7 minus 1 word context window, that is 6 words, to make the next prediction. So that's pretty much how the Markov assumption helps with this prediction process. Let's look at these different models. We're starting with the simplest form, which is the bigram model, right? So this are like the simplest form of n-gram models. It uses just the last word, like I said earlier on, to predict the next word. So for example, if you're looking at this graphic here, it says I am, right? So when the model is trying to predict the next word, it just makes use of the word am, because that's like the last word. It doesn't consider the I, it just looks at the am and then checks the corpus to see the word that comes with, like that comes after ham. So if you have, so the way it works is that if you have multiple occurrences of am in the text, it pretty much looks at the ones that occurred the most. So if you have like happy like 50% of the time, and you have here 30% of the time, there's a chance that the model will just return to you the word happy after ham. So that's it. It just considers the last word, a single word, to make the next prediction, right? And then for trigram models, this one's just take it a step further by using 2 words instead of one, right? So what it does is it looks at the last 2 words and then it uses that to make the next prediction. And looking at this example here, if you notice the difference, you realize that the sentence has changed, because previously it only had the context of ham to predict the next word, and the word that he found in his dictionary, in his corpus, was happy. So, and that's the word that he returned. But in this case, because I've added married to it, so it's considering I'm married to make the next prediction, right? So looking at his corpus, it appears that 2 is the word that appeared most after this combination of I'm married words, if that makes sense, right? So trigrams use 2 words, that's 3 minus 1 words context, to predict the next word, while bargrams use just 1 word, that's 2 minus 1 word, to predict the next word. So because of the way this behaves, you tend to have differences in what gets predicted, right? So like I explained earlier on, it looks at this combination. So for example, it looks at, for the diagram, looks at ham and looks at all the words that come after the word ham in the corpus, and it chooses the one that has the highest occurrence, like the highest probability, right? And then in this case, for a trigram, it looks at these two words, I'm married, to make the next word, to make the prediction. So in this case, it appears that in the corpus, two actually came more often than any other word after the combination of words I'm married, right? If that makes sense, we can proceed to um, scaling up to larger n-gram models, right? So what do you increase that value of n to a larger number, right? So can you predict what this model is, right? Looking at the formula that I gave earlier on, that for you to calculate the n-gram model uses, you use use the formula n minus 1. So if you can guess this, that'll be nice. And if your guess was, in this one, we are looking at 1, 2, 3, 4, 5, 6 words to predict the next one. So that means that you're going to add 6 to 1. That gives you 7. So this is a 7-gram model, right? So if that was your answer, then you're correct. Because the way we calculate n-gram models is we say the number that you're putting before your gram minus 1. And that's what the model uses to predict the next word. So in this case, the model uses 6 words to make the next prediction. And if you look at this sentence compared with the previous, we realize that the sentence has changed a bit again, because now the model is using more words to predict, right? So that's pretty much how it works. And one downside to having, one question that comes to mind is, so does it mean that if you have more words as context, that you're going to have better predictions? The answer is yes, and also no. So no, in the sense that, for example, for these basic n-gram models that don't use other complex algorithms, what happens is that if it doesn't find that word, these words consequently in its corpus, then it's not able to make a prediction. We're going to see that in the example later on in this video. So for example, if it doesn't see this, I'm married because I got engaged, in its corpus following each other like this, then it's not going to be able to make the next prediction. So that's one downside to having larger n-gram models, right? So that's pretty much it. Now let's look at the three models together, right? So for the diagram, realize that the sentence is, I am happy. So like I explained earlier on, happy is the most occurring word after the word ham. That is why the model suggested that or predicted that as the next word. But for a trigram, 2 is the one that occurred most frequently in the corpus. That's why you have I am married to. So the sentence changed a bit, even though we started with I am, things changed along the line, right? And then for the 7-gram model, we have I am married because. So it's the word coming after married is now because, right? Because that sounds good, right? So it's because in the corpus, sorry, in this case, so let's put it all together, right? My intention was to write I'm married because I got engaged to my best friend. That's the intention I had when I started typing this. But when I typed the word I am, the model came with this prediction of happy, which doesn't fit what I wanted, right? So I moved on further and I said I am married. Now the trigram model is considering the 2 words I'm married to make its next prediction. However, that doesn't still fit what I wanted, because this original sentence I want is I am married because I got engaged. So I took it over from the model and I completed it to the stage of engaged. And then the next prediction made more sense, right? So that's what we talk about when we say, for example, if you have like a larger n-gram model, you're going to get a better prediction. But then also, if the model doesn't find this combination of words that you want in its corpus, then it's not going to be able to make you a prediction. Let's look at the applications of n-gram models, right? So one common application of n-gram models is the plagiarism checker, which you find on applications like Grammarly and other, other places, right? So these models have a large data set or a large corpus. For example, when I was in school, my school used the Turnitin app, right? Turnitin software. So Turnitin uses, of course, looks at different papers, right? So for example, there's this ask to allow them to use a paper, right, in improving the software. So with this database of different projects, it's able to know if you have copied someone's project word for word. So for example, if you go online writing your project and you copy an entire section, the software is able to know that you have done some form of plagiarism, because in its data set it has this combination of words that matches yours. So that's why when you see when you run your project through softwares like that, it's able to highlight the words that appear in its own corpus, right? So that's pretty much how plagiarism checkers work. Right. So this is the Python script I wrote to demonstrate how n-gram models work. So we'll be looking at a bigram model, looking at a trigram model, looking at a sixgram model, and then we're going to look at what I mentioned about when you have a larger n-gram model. One of the limitations is that if it's not able to find those sequence of words in its corpus, then it's going to return an error to you. So, for example, if you look at the generate text part of it, if it looks at the seed tokens and realizes that it doesn't find a matching word after it, then it's just going to return can't predict. Or if anything else happens and it just can't generate a text based on what you have provided it as your context, then it's going to return can't predict to you as well, right? So let's look at the first example here. So this is my corpus domain that is very small. Normal big models have massive text in there for the model to work with. So in my case, if I put a word that is outside of this corpus, then it's just going to return nothing to you. So for example, if I say woo, there is no mention of woo in my corpus, right? So the model is not able to make any prediction out of that, and it's just going to return can't predict to you. So if I run this now, we can see that it says something like can't predict. So that's because this word is not in its corpus. However, if I put a word that appears in its corpus like shows, which I had earlier on, and I run it, then you can see that it predicts the next word as how, which is correct. Cool. Now, if I, for example, make a mistake with this, because these models are not so smart, they can't infer, they only work with what they have, then it's not able to actually, even though the word shows appears here, the model is not able to make a prediction. So if I run this, it's still going to return that it can't predict. So whatever word you're passing to it, this kind of models, these basic models only can make predictions based on what they know. So they've not been trained on, other complex algorithms that help them to make better decisions, right? So unlike the larger ones like ChatGPT that have been run through complex algorithms, those ones can make better predictions, those ones can do other things to infer that, oh, this person made a mistake here, probably wanted to type shows but type showed. Or if you make a grammatical error, ChatGPT is able to correct you, right? So that's because it has been trained, or it has been infused with other complex algorithms to help you make better decisions. Cool. So now let's go on to the next model, which is the trigram model. So trigram model uses it's n of 3, uses 2 word context window. So it's going to use this a simple to generate the next word. So a simple is here, and then if I run the example, we should see a simple example, because example is the word that comes after a simple. So it's going to consider both of this, not just one. It's not just going to consider simple, but both of these ones, right? So I can make you see that. So for example, if I do simple illustration here, right? So simple is here. However, because this trigram model is going to consider 2 words in its context window, it's still going to return this a simple example. So if I run it again, you're going to realize that it still returns a simple example back to me, right? So there is the trigram model. And for the 6-gram model, let's start with the correct example. So the 6-gram model uses 5. Sorry, this should be 6. So it uses 5 words. So 1, 2, 3, 4, 5. Right? And what we expect this to return is example of an n-gram model in will be the next word that the model will predict. So if I run this one, let me clear my terminal so we can see clearly. And I run this, then you're going to realize that it makes the prediction correctly because it was able to find these exact 5 words in its corpus, which is right here, example of an n-gram model in, and that's what you have there. So that's the prediction. Cool. So now let's go to the part where if you make a mistake or if it doesn't find, which I've shown earlier on anyways, let's show it again. So when your context window gets larger, so for example, when it gets to like 10 or 20 or something, if you're trying to run a 20-gram model, which considers 19 words of context window, then it has to look for all those 19 words to follow each other, right? So it's not able to break words and make smart decisions around how the thing should work. So it needs to find all of them following each other. So in this case, example of an n-gram model, but because I broke this here, it is not able to combine all this to make a prediction because instead of model, I've written models here. So that's one downside of n-gram models. So if I run this example now, you realize that it says can't predict simply because I've missed just one word. If I revert this back to model, then it's able to run it again. So that is one downside of very large n-gram models. I look forward to seeing you in the next one where we speak more about how the models calculate words, right? So I mentioned how they translate words into numbers and then back to words. We're going to be looking at that in detail in the next video. So I look forward to seeing you. Bye for now.